we start second part of the organometallic chemistry. In first part, we see what is mean by organometallic compounds, nomenclature of organometallic compounds, then synthesis and structural study of alkyl and aryl compounds of beryllium and aluminium. Now we see in second part of organometallic chemistry, we see what is mean by metal carbonyls, their types, what is mean by bonding in metal carbonyls, and we see some structure of metal carbonyls. So first we see definition of metal carbonyl. Metal carbonyl. So the complexes in which carbon monoxide is directly linked to the metal are called as metal carbonyls. Definition of metal carbonyl is the complexes in which carbon monoxide is directly linked to the metal are called metal carbonyls. So metal carbonyls are represented by general formula MXCOY, where M is the transition metal atom. X is the number of metal, that is 1, 2, 3, etc. CO is the carbonyl, and Y is the number of carbonyl. Okay, so general formula of metal carbonyl is MXCOY. The metals are in low, zero or even in negative oxidation state and act as Lewis acid, while carbonyl is act as Lewis base. That metal is acts as Lewis acid, while that carbonyl is acts as Lewis base. So depending on number of carbonyl group, metal carbonyls are classified into two types. Which types? That is mononuclear carbonyl and polynuclear carbonyl. Mononuclear carbonyl and polynuclear carbonyls. So mono means one, poly means many. So definition of mononuclear carbonyls is carbonyls in which one metal atom is linked with number of carbonyl groups are called mononuclear carbonyl. Carbonyl in which one metal atom is linked with number of carbonyl group. Are known as mononuclear carbonyl. For example, NiCO4, FeCO5, CrCO6, VCO6, where Ni is metal atom nickel, is attached to 4 carbonyl group. Here iron attached to 5 carbonyl group, chromium attached to 6 carbonyl group, vanadium attached to 6 carbonyl group. So all these are the examples of the mononuclear carbonyl in which only one metal atom is linked to number of carbonyl group. So what is the definition of polynuclear carbonyls? Carbonyls in which two or more metals are attached to number of carbonyl group are known as the polynuclear carbonyls. Carbonyls in which two or more metals are attached to a number of carbonyl groups are called polynuclear carbonyls. For example, Fe2CO9. Here two iron atoms are attached to 9 carbonyl groups. Or Mn2CO10. Two manganese atoms are attached to 10 carbonyl groups. So these are the example of the polynuclear carbonyls. So here we see the definition, representation and classification of the metal carbonyls. So most of the mononuclear carbonyls obey EAN rule. So what is mean by EAN? Most of the mononuclear carbonyls obey the EAN rule. What is mean by EAN? Effective atomic number. Effective atomic number. So what is mean by effective atomic number? The total number of electrons of the metal plus electrons donated by the ligands is known as effective atomic number. Total number of electrons of the metal. Total number of electrons of the metal plus electrons donated by the ligand plus electrons donated by the ligands. We see one example and understand that factor EAN. So for example, NiCO4. So in NiCO4 metal atom is nickel. So nickel contains how many electrons? That is 28. Carbonyl group donates how many electron? 2 electrons. Okay. Here how many carbonyl groups are present? 4. So here 4 into 2 is equal to 28 plus 8 is equal to 36. So number of electrons donated by NiCO4 is 36. So 36 is the atomic number of krypton, which is the EAN of NiCO4. We can see another one example, that is MoCO6. So molybdenum. So number of electrons of molybdenum is how many? 42. Number of electrons donated by 6 carbonyl groups is how many? 6 into 2, that is 12. Therefore total number of electrons is equal to 54. So 54 is the atomic number of xenon. Atomic number of xenon. Thus, the most of the mononuclear carbonyls obey EAN rule, or it is also known as valence electron rule. Now we see next point, bonding in metal carbonyls. So the metal in mononuclear carbonyls generally exhibits zero oxidation state. In mononuclear carbonyls, carbonyl group is linked with metal atom through carbon atom as metal carbon, like that, known as terminal carbonyl group. It is known as terminal carbonyl group. So how it appears? This is the orbital of the metal. So here that carbonyl forms bonding, likewise that here carbonyl okay, bonding. So this is metal orbital. So here the formation of metal carbonyl bond produces excess charge on this metal atom, excess charge. This bonding forms excess charge on this metal atom, which leads to substantial repulsion between negative charge on metal and that on carbonyl ligand. So here due to excess charge there is repulsion takes place. So to decrease this repulsion, vacant and pi star antibonding molecular orbital of carbonyl group accepts electron density donated by field ligand d pi orbital of metal. So what happened? To overcome or to decrease this repulsion, pi star antibonding molecular orbital of that carbonyl group which are vacant accepts electron density donated by field d pi orbital of metal. Likewise that this is dumbbell shape orbital, d pi orbital of the metal atom, dumbbell shape. So this is metal. So carbonyl having p orbital. This is carbonyl group. So what happened? This vacant pi star, that is antibonding orbital of carbonyl group, accepts electron from the accepts electron density donated by field, that is d pi orbital of metal. This one is the vacant pi star antibonding orbital of carbonyl group. This is known as synergic mechanism, and it is known as the synergic mechanism. So there is d pi p pi star back bonding, d pi p pi star back bonding interaction between metal and carbonyl group. Hence, in simple metal carbonyl compounds, carbonyl is said to be first sigma donor and pi acceptor, while metal is known as sigma acceptor and pi donor, and it forms the stable carbonyls with transition metals. It forms strong bonds, bonding in metal carbonyl. So here first time carbonyl group is act as the sigma donor, and in this case it act as the pi acceptor, while here metal is act as sigma acceptor and here metal is acts as pi donor, and it is known as the synergic mechanism. And now we start structure of simple metal carbonyls. Structure of simple metal carbonyls. From that we see first structure of NiCO4. Structure of NiCO4. So in NiCO4 metal atom is which one? Nickel, having atomic number how many? 28. Having electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6, 3d8 and 4s2. Okay, so we can write in ground state form, ground state of nickel as, so here outermost which orbitals are present? 3d. Here 4s containing how many electrons? 2 electron, and out of that 4p. So 3d contains how many electrons? 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. 4s contains how many electrons? That is 2 electrons. So here how many carbonyl groups are present? 4 carbonyl groups are present. So it is assumed that as 4 carbonyl groups come near and near to nickel atom, the 2 electrons from 4s orbital, 2 electrons from 4s orbitals are forced to pair into 3d orbitals. So in excited state of nickel, 3d contains how many electrons? 10 electrons. 4s orbitals becomes empty and 4p is already empty. So 1, 2, 3, 4, 5, 6, 7, 8, and that pair forced to pair up. That 1s and 3p orbitals are empty, and that undergoes which hybridization? sp3 hybridization. So there is formation of NiCO4. So how it is formed? So here 4 carbonyl groups donates the electrons. There is formation of the NiCO4. So as the type of hybridization is sp3, therefore structure of NiCO4 is tetrahedral. Hybridization is sp3, therefore structure is tetrahedral. So carbonyl molecules donate that electrons. The electrons donated by carbonyl groups. Okay, so here we can see the structure tetrahedral. Nickel, carbonyl group, here due to more negative charges accumulated on nickel atom by 4 carbonyl group, which is most unlikely. Hence, to maintain electron neutrality, according to Pauli, back donation of electron density from nickel to carbonyl take place and double bond is formed between nickel and carbon. Double bond is formed between nickel and carbon of the carbonyl. Okay, so one is sigma bond and other is pi bond. This one is pi bond, pi bond. Thus there is double bond formation take place between the nickel and carbon of the carbonyl group. According to recent concept, electronic configuration of nickel can be written as, so according to recent concept, outermost electronic configuration can be written as 3d8 4s1 4p1. So sp3 hybridization take place as 1s and 3p orbitals. So 4s1 and 4p1. Out of 4 sp3 hybrid orbitals, 2 are half filled. These 2 are half filled and 2 are empty. So here 2 half filled orbitals formed the 2 covalent bond, and empty orbitals form the 2 coordinate bond. And geometry or structure of NiCO4 can be written as Ni we draw structure per here. Ni these are the coordinate bond and these are the covalent bond. This is the sigma, 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 this one pi, pi. So this is the structure. This is also tetrahedral structure formed according to recent concept of electronic configuration. Perhaps double bonds may be changing their position very quickly. This tetrahedral structure is supported by X-ray and electron diffraction studies. This nickel double bond carbon bond length is 1.5 angstrom, while nickel single bond carbon are 1.82 angstrom. Okay, so remember that this is the structure of NiCO4. So in NiCO4, metal atom is nickel having atomic number 28, having outermost electronic configuration 3d8 4s2. So in ground state of nickel, it contains 8 electrons in 3d and 2 electrons in 4s. But when 4 carbonyl group comes near to that nickel, then what happen? These 2 electron from 4s orbitals forced to pair up into 3d orbitals, and in excited state of nickel, electronic configuration becomes 3d10, and this s orbitals remain empty, and it undergoes which hybridization? sp3 hybridization. As hybridization is sp3, geometry is tetrahedral. So likewise that here double bonds are present between the nickel and carbon of the carbonyl group. But according to recent concept, the electronic configuration 4s1 4p1, here 2 orbitals are half filled which form 2 covalent bond, and 2 orbitals are empty which forms 2 coordinate bond, and structure of NiCO4 becomes as it is. This structure is supported by X-ray and electron diffraction studies. According to that, the bond length between nickel and carbon double bond is 1.5 angstrom, and a nickel single bond carbon is 1.82 angstrom. Understand? Now we see the structure of FeCO5. Structure of FeCO5. If we understood the structure of NiCO4, then you can easily understand the structure of FeCO5. Okay, so in FeCO5, which metal is present? That is Fe, means iron, having how many atomic number? 26, having electronic configuration 1s2 2s2 2p6 3s2 3p6 3d6 and 4s2. So we can write that electronic configuration in ground state. So ground state of iron, so outermost orbital is 3d 4s and 4p, 3d 4s 4p. So 3d contain how many electrons? 6. 1 2 3 4 5 and 6. 4s contain how many electron? 2. So when 5 CO carbonyl groups, that is CO groups, when comes near to the iron, then electrons get paired. So in excited state of iron, what happen? This 6 and that 2 means total 8 electrons get paired. 1 2 3 4 5 6 7 8, and 1d orbitals remains empty. S and p orbitals also remain empty, and it undergoes which hybridization? DsP3. molecule undergoes dsp3 or sp3 dehybridization, then structure is which one? TPP, means trigonal bipyramidal. So these 5 hybrid orbitals forms the formation of molecule, that is FeCO5. So here 1 2 3 4 5 6 7 8, then that 1d orbital, 1s orbital and 3 p orbitals forms the FeCO5 molecule. So you know that as type of hybridization is dsp3, structure of FeCO5 is which one? Trigonal bipyramidal, trigonal bipyramidal, TBP. Okay, so how it is represented? TBP, FeCO5, CO, this one is equatorial CO. 3 COs are equatorial and 2 COs are at axial position. This is structure of FeCO5, that is trigonal bipyramidal. As all the electrons are paired, it is diamagnetic. Each CO group linked with iron through double bond, one sigma and other pi bond, to maintain the electroneutrality. Okay, so according to recent concept, electronic configuration of iron can be written as, so how it can be written as 3d6 4s 1 4p1. Okay, one 4s electron is transferred to 4p orbital. So dsp3 configuration, how we can it written as p3 1 2 3. Okay, this is 4s 4p and d 5. Okay, 1 2 3, this one 4s1 and 4p1, that is 3d. So out of 5 dsp2 hybrid orbital, 3 are half filled, that 3 are half filled and 2 are empty. So that 3 half filled orbitals form which bond? Coordinate or covalent? So covalent bond, and 2 empty orbitals form the coordinate bond. Coordinate bond. So the double bonds formed may be by the overlap of d orbitals of iron and suitable pi orbitals of carbon in carbonyl. So the structure becomes iron. Okay, 2 are the coordinate bond and 3 are the covalent. C triple bond O. 1 minute. Iron, C double bond O, C double bond O, 3 are the triple bond O. Triple bond O. Triple bond O. So this is the according to recent concept structure of FeCO5. Okay, understand? So here the equatorial bond length is 1.842 angstrom. Equatorial bond length is 1.842 angstrom and axial bond length is 1.797 angstrom. Okay, understand? And in last we see structure of CrCO6. Cr means which metal? Chromium. So chromium having atomic number how many? 24. Having electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6, 3d, 4s2 or 3d 5 4s1. Okay, so in ground state how we can write of chromium? 3d 4s and 4p, 3d 4s 4p. So 3d 5 4s1, 1 2 3 4 5 and 4s1. So in excited state what happened? Likewise that NiCO4 or FeCO5 pairing take place. So electrons get paired and 2d orbitals remains empty. So 1 2 3 4 5 6, that 2d orbitals remain empty and it undergoes which hybridization? D2sp3 hybridization. D2sp3 hybridization. Okay, so there is formation of, by using that hybrid orbitals there is formation of CrCO6 molecule. Likewise that. So here electrons donated by 6 CO group 1 2 3 4 5 6 and this formation of CrCO6. As here the type of hybridization is D2sp3, the structure of CrCO6 is which one? You know that, octahedral. Which one? Octahedral. So how it is represented? Octahedral structure. So here also at center chromium present, 6 carbonyl group are joined by double bond with carbon of carbonyl group. This is the octahedral structure of the CrCO6. As all the electrons are paired, it is diamagnetic. Each carbonyl group linked with chromium through double bond, that is one sigma and other pi bond, to maintain the electroneutrality. Sigma pi, sigma pi, sigma pi bond to maintain the electroneutrality. So according to recent concept of the electronic configuration, chromium can be written as 1s2, 2s2, 2p6, 3s2, 3p6, 3d, 5, 4s1. So which hybridization? D2sp3. So it can be written as 1 2 3 4 5, that is 3D. 4s, 1 2 3 4p. So 3D 5, 4s 1, 1 2 3 4 5, 4s 1. So out of 6 D2sp3 hybrid orbitals, 3 are half filled and 3 are empty. So here 3 bonds are coordinate and 3 bonds are covalent. The doubly bonded carbonyl groups are not replaceable easily, but single bonded carbonyl group are replaceable easily by strong electron donors. So according to that, the structure of CrCO6 becomes chromium 3R coordinate bond and 3R covalent bond. So these 3 are called C triple bond O, C triple bond O, C triple bond O. So this is the structure of the CrCO6. Here we completed the structure of metal carbonyls. From that we see the structure of NiCO4, FeCO5 and CrCO6. So structure of NiCO4 is, NiCO4 undergoes which hybridization? sp3 hybridization having structure tetrahedral. FeCO5 undergoes which hybridization? dsp3 and structure is TBP, that is trigonal bipyramidal, and CrCO6 undergoes which hybridization? D2sp3 and structure is octahedral. Remember that. Okay, thank you very much. So in organometallic chemistry topic, we see the introduction, then we see what is mean by organometallic compounds, then nomenclature of organometallic compounds, then synthesis and structural study of alkyl and aryl compounds of beryllium and aluminium. So in synthesis method of beryllium, we see the different preparation method, that is transmetallation, metathesis. Okay, then we structure of the beryllium compound, then we see synthesis of the alkyl and aryl compounds of aluminium. From that we see 3 different methods, that is transmetallation, then by using Grignard reagent, and by using aluminium hydride. Okay, then we see structure of that alkyl and aryl compounds of aluminium in part first. In part second, what we see what is mean by metal carbonyl definition, their representation, their classification, that is mononuclear carbonyl and polynuclear carbonyl. It obeys the EAN rule. How it obeys the EAN rule, we see that. Then we see bonding in simple metal carbonyls. It shows the synergic mechanism. Okay, then next we see structure of metal carbonyls. From that, first we see structure of NiCO4. So NiCO4 undergoes sp3 hybridization, shows tetrahedral structure. Then we see FeCO5. In FeCO5, iron undergoes which hybridization? dsp3 hybridization and shows structure trigonal bipyramidal. And last one we see CrCO6. In CrCO6, chromium undergoes D2sp3 hybridization and structure is octahedral. And we completed the organometallic chemistry topic from the inorganic chemistry paper. So you, for another videos, you can subscribe my Swapnali Jadhav channel, like and share to your friends. Okay, thank you very much.